The challenge number one is inter-service, inter-API communication. Right? Now you need to solve that, and that has to be very foundational again.
Now everything is built to be cloud native from the get-go. Through this, we can achieve incredible scalability and resilience.
Now that everything is a microservice or a little service deployed in a larger environment, where is the visibility of what's doing what, how are they performing, what's failing, what's running?
Hello everyone, welcome to another Our Tech Chronicles podcast. Today's topic is a technical one. We're going to explore cloud native architectures. The areas we're going to cover are common misconceptions of cloud native. We'll talk about the foundational components that make up a cloud native architecture. We're going to explore challenges in adopting cloud native and considerations you should make. And we'll end up with some real world examples. Sounds good?
Very good.
All right, let's get started. What are these common misconceptions of cloud native?
Yeah, so in general, people talk about taking their existing application, probably on a data center or on-prem, towards the cloud, and having an objective of this solution not being specific to a cloud platform provider. So it's not specific to AWS, it's not specific to Google, or and that's what we call the portability, and they sort of contribute the whole cloud native architecture towards that. I think that's a very limited or rather misconception of it.
Yeah, so maybe I can expand to that, right? I like what you said. Cloud native is not the same as moving to cloud, right? What some companies do is they do something called a lift and shift. They just take what they already have in their data centers and then just deploy that in the cloud. You're not making use of any of the, like Anjana said, offered by the cloud platform. And so you're not really cloud native, right? And you're not getting any benefit out of that. In fact, sometimes the cost is even higher when you do that. What we want to do is take the benefits of moving to the cloud, like managed databases, managed services, serverless, things like that. We will explore in our next topic. But that is the whole misconception between just moving to the cloud and really being cloud native. Did I cover that correctly?
Yeah, I think so. I think that you got that right. For you to be cloud native, the portability is important. So the ability to operate across multiple platform providers, multiple cloud platform providers is the true native part. But with that, when you do that, there are other benefits and practices that you inherit. Whole thing is being cloud native, but the portability is what most people talk about, what most people want to, because then they are not locked into a vendor. That vendor locking is taken out, which is a very big concern to most of the product startups or building products or even enterprises. They don't want to lock themselves into a single cloud platform provider. Right? They want their footprint across.
We can let's talk about that. That's an interesting topic, and I have some examples to share there about the downside of vendor lock-in. But there's also a positive too, because especially for big companies, if they maintain a relationship, they get first dibs on almost everything with that cloud provider. I don't think it's a big negative, as you say, Anjana. It depends on the company and the market that they operate in, right? Who are they serving? Because sometimes you over optimize unnecessarily. Like for a small company, I feel there's no need to be able to deploy in AWS and GCP and Azure. I feel there's unnecessarily optimized. Sounds good. Let's change gears. Let's talk about these foundational components of cloud native.
Yeah, so I think there are subcomponents of the foundational. One of the pillars of that for me is the application architecture itself. So if you have a monolithic app, your natural tendency is to sort of do a lift and shift in a cloud server and then That's pretty much it. After that, if you want to scale, you can't do scaling as much as you like with a more decomposed architecture. So elements of the application architecture are the popular buzzwords like it has to be microservice driven or some sort of service driven where the services can be independently deployed into multiple instances or other containers, the scale up and the scale down capability, what we call the scalability, right? Up or down. That ability needs to be part of the application architecture.
I totally agree. The value there is, like, if you take the monolith, right, it's honestly like a single point of failure, right? And so you lose things like resiliency. If something goes wrong with the monolith, you probably potentially have downtime. With what you suggested, Anjana, when you break that down into, like, or decompose the monolith into microservices, then what happens is each of these independent services are deployed. They scale independently based on the load, and even if one microservice fails, the rest of the application can still operate, maybe in a degraded manner, but it's still operational, right? Users can still do as much as they can, and then this independent service can be self-healing, restarted, and whatnot.
Yes.
That's one of the
Yeah.
benefits of architecting in that manner, right?
Architecting that. I know there are lots sort of two different thought of schools in terms of whether to go down microservices or not. I mean, we are not here to argue on that one. Maybe you can discuss that in the comment section. But fundamentally, if you want to adapt a cloud native architecture, having decomposed services which can be independently deployed and scaled is a must have. And how you do that, whether you do that as microservices or in other form, it's up to you. But what is definitely no is a monolithic. That's what the starting point of the application architecture. Cool.
Absolutely. Another advantage also of having a microservices or decomposed set of services in your architecture is that it allows you to use the best tech stack for that particular service. So they call it polyglot programming, right? So if a particular service is best built in, let's say, Golang, boom, you can do that now. And if something else has to be built in Java, you can, as long as you have a strong API contract on how they communicate. So that's a foundational component. Cool. What else? If you like content like this, don't forget to hit subscribe.
The other part is the so I would bring this development process, right? Predominantly the DevOps part of it. Now that you're cloud native, sort of cloud first type of development house, what do you need and the culture and the practices that you need to bring it in. So fundamentally, you need a CI/CD pipelines where we can take it to the right cloud environment, deploy it, automation, sort of automation testing. All that is something fundamental to this, and you need to bring that culture and those practices into the play. What are your thoughts on that?
Yeah, no, spot on. Just to expand to what you said, right? When you're on-prem, um, you know, the tendency is you have silos in teams. You have a development team, you have a testing team, you have an operational team, right? But all those silos break down when you have this whole microservices architecture. Every team, we follow that. We follow this thing called you build it, you own it. Meaning, we are the ones who design and build this. We test it. We are responsible for deploying it. We are responsible for its metrics and operationalizing of it, right? So to cover Anjana's point, it's all in our best interest. There's no, throw it over the wall for someone else. And that's the only way this scales, because you're looking sometimes for large companies like 2,000, 3,000 microservices. You cannot have separate teams that do all this, right?
That's right.
So that's very important.
That culturally,
Another,
you own
Mhm.
it. You own end to end. That's
You
what
own
it
it.
is. From building to
Exactly.
all the way taking to production, you own it. That ownership gives you as much as independence, you're also accountable for what you do. It's not like you build something and give it to the QA team or to the implementation team, which becomes their job. Rather, it
Yeah.
becomes your baby from birth to high school or to university, something like that. That's That's where you have to be more focused and you have to be more disciplined to capture all of that, and that has to reflect in your estimates, that has to reflect in your team capabilities. That's the cultural element, I would say. Cool.
Yeah. Another point I think maybe we didn't talk enough about was when developing like the microservices architecture, right? Is you also want to follow an API first approach or APIs as a first class citizen, because that is the way other services are going to call you. So you first standardize your API, make sure it's published, it's versioned correctly, right? It's easily understandable, because that's like the language you're going to talk to everyone, the outside world. And then you build out your service, and you pay special attention when you want to, version it or make changes to it if there are breaking changes. This, to your culture point, that's another cultural thing that you need to start getting used to, right?
Very, very good point. Now that's a very good capability that you introduce, right? You introduce the ownership and you make everything API driven, service driven. Now the deal is, when you do that, there are two challenges come into play, for me at least, right? The challenge number one is inter-service, inter-API communication, right? Now you need to
Yes.
solve that, and that has to
Yeah.
be very foundational again, because you have so many services and they are independent, and if you want them to communicate to each other effectively and a very reliable communication, that's a capability that you need to build. There are patterns like sidecars and so much of patterns into that. We can talk about it. The second challenge that brings, now that everything is a microservice or a little service deployed in a larger environment, where is the visibility of what's doing what, how are they performing, what's failing, what's running, what we call the traceability, which translate into the observability. Now that's a bigger
Yep.
challenge, and you need to have a
Yep.
right kind of tools, practices, tech in place to tackle those two challenges. So services bring you much more capabilities. You can work with your own teams, you can work with your third parties, but these are the challenges. Unless you have
These are challenges.
these
Yeah.
two challenges tackled properly, you don't know what's failing. Very hard to say, because it scales up, scales down, and you don't. Sometimes an instance comes up when there are people, when there are more load, and that instance gets killed. So if you don't have a proper way of monitoring, you never know the issues that arises when there's load. So that's part of the observability
Yeah.
that you need to tackle, right?
Yeah, very good point. That was the next thing I wanted to talk about. So perfect. It's like three things actually there for observability. One is so metrics and monitoring, more important now in distributed systems. Then distributed tracing, right? For troubleshooting, you need to know what happened where and where did it drop. And the third thing is a centralized logging platform. There's so many open source tools out there, right? But I think those things have to be embraced now by the teams and whatnot, because that's how you're going to
Yes.
solve problems.
Cool. I think,
There's another one I can bring up with
yeah.
cloud native as a foundational piece is the security aspect actually. So when you're in a on-prem, your security is your perimeter, right? So you can protect the perimeter because everything inside is yours. It's your data center. When you're in the cloud, that's not true anymore. So you have to follow this thing called zero trust, where every service is revalidating or authenticating the request, checking policies, right? Because now the surface area for attacker is bigger, right? There's so many services to exploit. So you have to have these policies in place of like least privilege access, things like that, where every service is taking security or tackling security on its own. Would
Yeah,
you agree with
very,
that?
very good point. Very good point. So that leads to another very important foundational component which we didn't touch upon, is the when you have APIs, you need a API gateway. The
Yeah,
Before
there
we
you go.
explain the
Yes.
gateway part of it, the access, in a simple sense, you have public access and private access. So some people name it differently. Some people say the experiential API versus the system API, the process API. You can come up with some names, but it's predominantly based on who you can access, who's able to access. There is public API and a private API. And based on whether it's public or private, your security measures are different. And how do you implement something like this? Because there is no UI, but this is rather API. Most of that is at the API gateway and the security management, which is plugged into the API gateway. So the identity management and all that, which is plugged into API gateways, can provide that security at the time of when the services are accessed. Once a service is accessed, the journey downwards needs another security thought.
That's exactly how we do it as well. So we have an API gateway that takes care of common concerns for an what should I call it? Inbound request from the public. So it takes care of auth N, auth Z, uh, IP allow listing, rate limiting, export control, things like that, right? Common things from an inbound request, north-south request. But once the request is in, it doesn't mean it's safe anymore. For us, even service is HTTPS, right? Every service has its own authentication. All these certs are rotated. So I mean, we take security at a different level just to protect it, because all these vectors can be exploited, right? So just like to your point, yeah, another level of security. One more thing I want to just quickly talk about, the last thing I think for foundational components is actually the native aspect of cloud, which is like serverless. Right now, you don't have to spin up a server depending on the type of use case you're working on. If it is sporadic, you don't need to spin up a server and spend money. You can just do pay as you go and use serverless, where you're just paying for your usage. So those are things that you have to learn to use. Manage databases, right? Key value stores, queues, right? Things like that AWS, sorry, or GCP or whoever, what they provide, you don't have to implement these anymore. You just use this service, it scales automatically, and you just reap the benefits of that.
Yes. So when you are architecting the core services that you need to build, which roughly no one has built for you, is one part of it. The other part is utilizing the platform capabilities. So it can be any of these cloud services, but moment you are again to that portability point, again when you use any of these platform provided capabilities, you kind of you you kind of get locked in. But that's all right based on the trade-off that you do, based on the trade-off, and that's so as long as you in your architecture you're clear about what you build, what capabilities you use, and so on and so forth, and there's justification, you're still all good, right? As long as all of that is in the cloud, so that you're thinking cloud first, cloud native type of architecture there.
Yeah. Actually, I just remember one more thing for the foundational piece is also you have to think of infrastructure as code. So all the mechanisms of how you spin up an environment, a
Mhm.
cloud, the properties, the configurations, it can't be human driven. It has to be, terraformed or cloud formation
It's
in AWS or things like that,
IAC,
so that it's
IAC.
now push button, right? And you can quickly spin up an environment as quickly as possible. It's error free, right? There's no fat fingering. It's very repeatable, right? As well as you can tear it down if you want. But I think that's another piece that some teams forget, isn't it?
Yeah, so when we talk about containers and orchestration, they're something very fundamental to for a container, and that orchestration is the IAC, infrastructure as code. And
Mhm.
having that script makes you much better at your containers and container orchestration. So yes, we kind of missed that point, but yes, it's something needed in that whole deployment and packaging environment management scenarios for you to be more efficient.
Yeah. I think, Anjana, open to your thoughts, but I think we kind of covered some of the challenges as well while we are
I think
talking about this.
we challenges. The only thing is left in my mind are the case studies, and
Yeah. Shall we go into case studies?
yes, let's do that.
Why
I'll
don't you go
start with
first?
you. Okay. So I'll start with a very recent consulting gig where I was talking to the client. The ask was they have already invested on a data center, and that data center has a computing virtualization. So What that means is you can log into a console and create instances, but the actual hardware is limited and capped, but multiple virtual instances can be created. But however, now they have figured they're coming to some of the limits of the hardware underneath. Even though they have virtualization, your hardware is a limitation, right? They want to go to expand this. They need a solution. They have footprint in other cloud platform providers, but the way they were thinking, each platform provider to have a team to build applications specific to that. Like for instance, their data center, a team to build services, AWS, another team, if it's GCP, another team. So eventually, the team structure is not justifiable. It boils down to architectural problem. That was the problem presented to us, and I was one of the. So I was the lead architect, and there are multiple architects looking at it from how to solve this. The solution that we came up. So we understood portability is a clear requirement there. So it's a one team builds things, and you should have the capability of deploying that across the clouds. So that portability was very important. Where we built practice, we also sort of introduced IDP, a developer platform, where that developer platform takes care of environments, the containers, container deployments, IACs, all that, where developers logging in and they say create a microservice or create a service, and they work on the functional aspect of it. Rest is abstracted to the developer platform, and which takes it to the appropriate environment. So because they have done the investment, like already invested on the data center, we give the priority, which is also cloud, right? You can call it a private cloud, and then whenever it's not enough, it takes it to other environments and utilizes that scalability. And that was purely achievable because we looked at a very cloud native architecture with the portability. That's the trade off there. And they, with all of those technical architectural changes, now they can still continue with the same team they have, but a layer of developer platforms and architecture, they can go into multiple cloud. We call it a hybrid cloud based scenario. That's a very good advantage, and they benefiting quite well with that architecture setup. So that's the case study I have. Though.
That's a good one. That's a nice one. I like that. I can talk about my current company, Atlassian. So Atlassian products used to be, monoliths. Jira Confluence were monoliths, right? And they were many years ago. They were designed to be data center and on-prem solutions. But over the last, I don't know, maybe 10 years, we've embraced the whole cloud native approach. Right now, everything is built to be cloud native from the get-go. Through this we can achieve like incredible scalability and resilience. And so what we've done, I can club Jira and Confluence together. We've started decomposing the monolith, re-architecting each of these microservices to use the appropriate cloud native capabilities as much as possible, right? So we use like lambdas to handle bursts, notifications. We use event driven architecture as much as possible, using like kinesis, for example, to fan out, fire and forget type messages. We use obviously auto scaling with limits to handle like workloads, whatnot, right? And we use serverless, to reduce costs for things that are like sporadic, like what I mentioned. We have a very close partnership with AWS, and so because of that we get like first dibs on a lot of things. There's a lot of value in that. And then we heavily use like AWS primitives, Kinesis, SQS, SNS, RDS, Postgres, um, DynamoDB, S3. You name it, we probably are using it. Their firewall, whatnot, right? We're probably using it. And then on top of that, we built, this is maybe about now 7 8 years ago, we built our own pass, which which was homegrown, right? And it did all the things we wanted to do, right? But now we've come to a point, interestingly, right, where we are starting to think of like cell-based architectures and being portable to different clouds, because some customers who were on data center previously want to use our cloud, but want to use a different cloud for different reasons, competitive advantage, whatnot, right? So now we are trying to think of, okay, introducing Kubernetes, right? So that we add this portable layer to what Anjana pointed, and then being able to, deploy like a cell in a different cloud platform. I mean, you can imagine with the a scale we have, it is a ginormous task, right? And so we're going through that right now. So, but it's a fun journey. From other tools we use, so we use Spinnaker as our CI/CD pipeline. We use Signal FX as our metrics provider, and Splunk as our centralized logging platform. A lot of things are also homegrown. So that's one. And another interesting use case I want to share is, Jira and Confluence. We allow third-party developers to build apps on top of them, right? And in the data center world, it's different, where we had the app developer spin up their own instance of the app, and there's a connect protocol where it connects with the Jira or Confluence instance. Recently, we rolled out a couple of years ago, we rolled out a game changing platform called Forge. It is completely built on serverless, on Lambda. And now the developer can just deploy code. It runs in an isolated environment. It scales on its own. They don't need to worry about scaling. It is secure by default because every app is is in its own like sandbox, right? There's no leaking of information. So it is actually changed the way app developers contribute to Confluence's ecosystem, and that has now taken off on its own. So many more people have, and companies have formed just building apps and making money out of building apps on top of Confluence and Jira. So that's another cool thing, and that's because we just embrace this whole cloud native architecture. Shall we wrap it up there?
Yeah, let's do. I think it was a good talk. We touched upon lots of areas and different perspectives. So that's really really good.